textile supply chain, concept to consumer.
รายกิชอนยักหนึ่งมาโจ้จอดสองแอนอีแฟนอูลากสอง1 School of Communication and Design IMIT University เวียดนาม702อึนกาเยื่นแวนลิง District 7โฮชิมินห์เวียดนาม2 School of Business and Management IMIT University เวียดนาม702อึนกาเยื่นแวนลิง District 7โฮชิมินห์เวียดนามรายกิชอนยักอีเมลรายกิชอนยัก @imit edu vn abstract
Fashion and textile products evolve through several processes that involve the conversion of fiber to yarn, yarn to fabric, and fabric to garment. During these processes, there are numerous wastes generated, which reduces the productivity and efficiency. Many of the manufacturing facilities in developing countries still follow the traditional technologies for manufacturing, which leads to low productivity, more energy consumption, higher waste.
and low product quality
The global marketplace is getting more and more competitive day by day with demand on high value-added products at cheaper prices. The fashion and textile manufacturing industries need to fulfill the demand for quality and price by improving their performance. Further, with the growing global interest on sustainability and increased consumer awareness, fashion and textile industries bring sustainable solutions in their production lines by reducing wastes. This can be achieved by the implementation of lean manufacturing in the manufacturing industries, which is the focus of this book. This chapter is the introduction to the fundamentals and concepts of lean manufacturing. A brief introduction has been given on the fashion supply chain starting from concept to consumer, which is essential to understand the problems associated with the manufacturing industries. Further, the principles and tools of lean manufacturing are also discussed, including the 7 wastes in manufacturing industries for fashion and textiles. The steps to implement lean manufacturing, which includes PDCA, Plan Do Check Act, cycle, advantages and disadvantages, and future directions are discussed in this book. Keywords: lean manufacturing, fashion supply chain, fashion sustainability, push and pull, waste eliminations, lean tools, lean principles.
1 Introduction
In many developing countries, the manufacturing of fashion and textiles is labor-intensive using the traditional technologies. In spite of the availability of automation, many industries still operate with the traditional machineries, which are at odds to achieve the objectives of good quality and high productivity. In addition to using higher energy, the traditional technologies generate more wastage.
and Greenhouse เกษตรมีอินิมากิเอตเอา2020นยักเอตเอา2021
The global demand of fashion and textiles is fulfilled by the manufacturing services of industries located in developing countries. There has been paradigm shift of manufacturing from developed countries to developing countries. The developing countries such as Vietnam, Cambodia and Bangladesh are the leading manufacturer of fashion and textiles. The manufacturing activities in China and India, the past leaders, are gradually declining in the drive of keeping the cost of production low. The fashion and textile manufacturers in developing countries are operating in stiffer competition in the global marketplace. The increasing labor cost, rising utility charges, increase in the cost of materials and demand for sustainable fashion and textiles has made it difficult for the manufacturers to produce the products.
at cheaper price
Many of the large enterprises in these countries have well coped with the global demand due to larger volume of production and timely investment on new technologies. Nayak et al.
2020B
However, there are several manufacturers of raw materials, trims, semi-finished products, and final garments, especially small and medium-sized enterprises (SMEs), who cannot upgrade themselves due to
financial problem
hence, they still operate using the traditional technologies. The use of traditional technologies may not be able to deliver the productivity and efficiency that can be achieved by the new technologies. In addition to traditional technologies, there have been loss of productivity due to improper allocation of resources. Problems such as excessive reworking, improper line balancing, and lack of synchronization have also added to productivity loss.
อากายานีเอตเอา2012นยักแอนปาไฮ2015
Rework is a general problem in many industries due to lack of intermediate inspection during manufacturing. The products are fed to the next operation sequence without inspecting any defects form a process. Hence, A small defect in any process is translated into a larger defect in the final product, which then fixed after the final inspection of the finished product. Inspection of the final product is too late to fix the fault to improve the product quality. This requires reworking from the step when the defect occurred. Rework can be mainly related to stitching defects, skipped stitch, and broken stitch, seaming defects, open seam and seam puckering, fabric defects and other sewing-related problems. These defects are fixed by rework, which lowers the productivity and sometimes rejection of garments. Rework impacts the regular productivity and have an impact on the manufacturing economy. Improper line balancing and lack of synchronization is the problem of mismatching of supply and demand among various sections in the manufacturing process. These non-productive activities need to be reduced, for which the implementation of lean manufacturing plays an important role. The garment supply chain can be characterized by high volatility, small production volumes, wide range of styles, short production life cycle and low predictability, Ren et al.
2017 มาสันโจนส์ et al. 2000
Furthermore, there have been a decrease in volume of production for specific products and increase in the style variation, which creates challenges to source a range of raw materials such as fabrics, trims, and accessories. Earlier, when there were large order volumes, the manufacturers were ascertained the manufacturing will continue for several weeks or months. However, decrease in order quantities has led to frequent change of product lines, increased sourcing activities influencing the profitability. In order to cope with these changes, the garment manufacturers need to focus on the implementation of lean manufacturing. The concept of lean manufacturing is based on reducing waste, reducing inventory, increasing productivity and efficiency by reducing the amount of rework. Majority of the clothing manufacturers in developing countries follow the Progressive Bundle System, PBS, which aims at mass production of apparels, Desai et al.
2012
In the PBS systems, the work related to a specific garment is performed progressively one after the other. Machines and equipment are arranged sequentially depending on the type of the garment forming an assembly line. Multiple assembly lines can be used for a specific garment style. Garment components after cutting are supplied to different assembly lines in bundles, which moves across the assembly line in trolleys by the workers. In PBS approach, each operator only does a specific type of job repeatedly and pass to the next operator. The PBS system is labor-intensive, which involves high amount of non-value-added activities and larger lead time due to longer waiting time. If any operator in the PBS line is not manufacturing at the expected level, the whole line is impacted due to slow productivity. The PBS system can be classified as batch manufacturing, which is always limited in terms of productivity. The machine arrangements in a PBS system as has been shown in Fig.
1 Fig
1 PBS system in a garment manufacturing industry. To overcome these limitations, the PBS systems can be replaced with the cellular manufacturing systems or unit production systems, UPS. In UPS system, the cut pieces hanged in hangers are automatically transported by overhead conveyor system. One hanger carries all the components for a garment, which is transported automatically. Hence, the manual operations are replaced with automatic transport system. A garment is manufactured through the different steps of production and the final garment is hanged back in the hanger system. The implementation of lean manufacturing can produce better results in UPS manufacturing process compared to the PBS concept. However, the UPS systems cost a lot more and needs highly skilled operator for successful operation. This chapter discusses the basics of fashion and textile supply chain with a special emphasis on lean manufacturing. The problems of traditional manufacturing and necessity of lean manufacturing has been discussed. The fundamental principles of lean manufacturing have been discussed with the 7 wastes in the fashion and textile manufacturing. Various tools used in lean manufacturing and steps followed for the implementation are discussed. This chapter also highlights various approaches to become sustainable by the implementation of lean in the fashion and textile supply chain processes. Furthermore, the advantages, disadvantages of lean manufacturing and the future directions are discussed in this chapter. 1.1 Fashion and Textile Supply Chain. Supply Chain Management (SCM) deals with the management of the supply or flow of goods and services. SCM involves the procurement, storage and flow of raw materials. Semi-finished and finished goods from the point of origin manufacturing to the point of usage consumers, Ross 2015, Stock and Boyer.
2009
A network of upstream and downstream players is interconnected to produce the products and services required by the consumers. SCM is the management of flow of goods and services that is required to convert raw materials to finished goods for the consumers. The main objective of SCM is streamlining supply of goods and services to maximize customer satisfaction with right type of products or service. Christopher 2016. SCM can be defined as the design, planning, execution, control and monitoring of supply chain activities with the objective of creating net value, building a competitive infrastructure.
Leveraging World
Wide logistics, synchronizing supply with demand and measuring performance globally, Tawari and Jane 2013. SCM can relate to the distribution activates in many sectors such as automotive, medicine, construction, hotel, hospital, engineering, information technology, plastics, fashion and textiles. The supply chain activities in fashion and textiles are rather complex and involves many role players as shown in Fig. 2, which starts from the fiber producers. Fibers are known as the building block for fashion and textile manufacturing. Textile fibers can be classified into two groups, A, natural and B, synthetic. As per the name, natural fibers are derived from natural resources, which includes cotton, wool, silk, hemp and jute, Nayak et al.
2012
On the other hand, synthetic fibers such as nylon and polyester are derived from the petroleum resources, whereas synthetic fibers such as viscose, modal and lyocell are derived from plant resources. Therefore, the synthetic fibers derived from plant resources are known as semi-synthetic fibers or regenerated fibers. Fig. 2 sequence of operations for garment manufacturing. The next level of midstream players includes processes such as spinning and weaving industries, who produce yarns and fabrics, respectively. The yarn manufacturing process uses various fibers as the input material and produces different types of natural and synthetic yarns. Yarn manufacturing process can use different spinning systems such as ring, rotor and airjet to produce a range of yarn counts with different properties, Goyle and Nayak 2020. Ring spinning is the versatile system and produces the strongest yarn among all the systems. However, the energy consumption is the maximum for the ring spinning systems. Other spinning systems, such as rotor and airjet, consume less energy. However, there are some limitations in producing a range of yarn counts and the yarn strength. When productivity is considered, ring spinning may be considered at odds due to lowest production and highest energy consumption. However, one must consider factors such as end-use application, cost, type of product and downstream processes while selecting a yarn from various spinning systems. Fabric manufacturing follows the spinning process and can be broadly categorized as weaving, knitting and nonwoven, Patnaik and Patnaik 2019. Weaving is the most widely used process for manufacturing fabrics, which involves the interlacing of two sets of threads perpendicular to each other. The next widely used process is knitting, which involves the intermeshing of consecutive rows of connected loops with the next and previous rows. Nonwoven fabrics are rather weaker structures directly produced from the textile fibers, staple and filament, bonding them together by means such as mechanical, thermal, chemical.
Solvent treatment
Woven fabrics vary in their structure and can be classified as plain, twill, satin, sateen, and many other structures. Knitted fabrics can be classified as single jersey, purl, rib and interlock, which have different structure, hence, vary in their properties. Nonwoven fabrics can be of various types such as spun-laced, dry spun, melt-blown, air-laid and heat-bonded nonwoven fabrics, which also differ in their structure and properties. Each type of fabrics has its merits and demerits, and the selection of a fabric depends on the type of product and end-use applications. For example, woven fabrics are used for apparel clothing, such as shirts, trousers, ladies' dress and activewear, home decorations such as curtains, bed sheets, draperies, bed towels and tablecloths. Uniforms such as security, police and army, and industrial applications. Knitted fabrics are used for apparel clothing such as tees, jackets, coats, jumpers and pants. Innerwear such as camisoles, undies, girdles, sleepwear and vests, sportswear such as sock, sports shoes, tracksuits and vests, home furnishings such as cleaning wipes.
Laundry
Bags and mosquito nets, and automotive textiles such as headrest lining, Cushioning material and lining for motorbike helmets. Nonwovens are used for medical textiles such as surgical masks, surgery.
แคลโกน เกลิฟ วีเบส แคป พลาสเตอร์แอนด์วอลเดรสซิ่ง ฟิลเทรชั่น such as vacuum bag filter membrane for gas and liquid and unlagen membrane geotextile such as erosion control canal
Liners, soil stabilizer and drainage systems. Sinclair 2014. The fabrics manufactured by various processes, as discussed above, are in greige state and not ready to be converted into a garment. Greige fabrics are in unfinished state directly coming out of a loom or a knitting machine, which contains impurities such as wax, oil, gums, soluble impurities, and dirt in addition to the sizing moth.
material
These impurities make hard for textile coloration by dyeing and printing. Hence, these impurities need to be removed by various chemical processing steps before they are ready for garment making. The chemical processing steps include desizing, scouring, bleaching, dyeing, printing, and finishing. Among all the upstream and downstream processes of garment construction, the textile chemical processing is the most polluting step as it produces the maximum amount of wastewater, Mutu 2018. Therefore, any drive to reduce wastes, especially wastewater, during fashion supply chain should emphasize on the textile chemical processing. Fabric chemical processing makes the fabrics ready to be converted into garments. The next process is garment manufacturing, where the two-dimensional fabrics, 2D fabrics, are converted into three-dimensional garments, 3D garments. The garment manufacturing process involves activities such as fabric inspection, spreading, cutting, bundling, fusing, sewing, ironing, inspection and packaging, Nayak and Padye 2015. The global trend in garment manufacturing has undergone many changes from the beginning of the 21st century. The global demand for apparel textiles is being fulfilled by only some developing countries such as Bangladesh, Cambodia, China, Laos, India, Vietnam and some countries in the European Union (EU). The manufacturing of garments at cheaper prices in developed countries such as the US or Australia or Canada is not viable due to high labor cost and energy charges. Therefore, they rely on the developing countries to fulfill their demand for fashion and textiles. In developing countries, the fashion and textile industries provide employment to a large section of the population. This sector also contributes largely towards the gross domestic product, GDP, of the countries Nayak et al.
2019
Earlier, the manufacturers in developing countries were getting larger orders in bulk quantities, which is easier to control. Once the production line is set for bulk orders, it would be running for some months or even some weeks. However, the order quantities are shrinking nowadays. The garment manufacturers have to change the line setting in some days or few weeks. Further, the raw materials and trims are sourced in smaller volumes, which reduces the flexibility and profit margin. The volatility and shrinking volume can be better managed by the implementation of lean manufacturing in the production floor. The competitive global marketplace is creating a lot of challenges for the fashion and textile manufacturers. The demand for low cost by fashion brands has necessitated to increase the efficiency and productivity in the manufacturing process, Charnin and Vienazindin 2014. The traditional manufacturing processes are at odds if high productivity and efficiency are claimed. Hence, the manufacturers need to invest in the new technologies and automation to replace the labor-intensive processes. The automation technologies can be implemented at any stage of the manufacturing processes of fashion and textiles starting from fiber production to garment manufacturing, Nayak and Padye 2017.
2018B
Furthermore, the investment in the automation and new technologies need to be appropriately operated to reduce the wastes from the manufacturing processes, which can be achieved by the implementation of lean manufacturing. Hence, it can be concluded that lean manufacturing will become an indispensable part for the fashion and textile manufacturers in the future.
1.2 Fundamental of Lean Manufacturing
The business environment is rapidly changing for the global fashion and textile enterprises due to reduced profit margin, demand for high-quality product, high product varieties and increasing pressure to reduce the lead time. In order to stay competitive and survive in this environment, strategies such as enterprise resource planning, ERP, quality management, ISO 9000, total quality management, TQM, just-in-time, JIT, or quick response, business process re-engineering, and lean manufacturing are essential. Schonberger 2014, Fink 2003. Among these, the most significant for the manufacturing industries such as fashion and textiles is the lean manufacturing. The lean manufacturing approach has been widely adopted by many fashion and textile enterprises in order to enhance productivity, efficiency and to achieve the desired quality. Carmignani 2016. The operational costs in garment production can be reduced by adopting the concept of lean manufacturing, which focuses on eliminating the process waste, improving productivity, empowering people with greater communication, and converting the organization into a learning organization. Bruce et al.
2004
The process waste can be reduced by avoiding overproduction, wastes, waiting time, unnecessary motion, unnecessary transportation, improper inventory management, and overprocessing. Continual improvement, generally known as the Japanese word kaizen, is the major principle of lean manufacturing. Kaizen promotes continuous and necessary changes, big or small, towards the achievement of a desired goal. The fundamental thrust of lean manufacturing is to produce a high-quality product at lower cost by reducing or eliminating the 7 cardinal wastes such waiting, inventory, overproduction, repair, inappropriate processing, excess motion, and transportation from the value stream through continuous improvement and to deliver the value to the customer. Benders and Van Bijsterveld 2000. The goal of the lean manufacturing is to create an integrated system using multi-dimensional approach that includes adoption of management practices such as pull strategy, just-in-time philosophy. 2.
เข้า Quality Management Cellular Manufacturing Electronic Data Interchange EDI Kanban and Company Design.
Lean production techniques create a sustainable and positive work environment by emphasizing on empowering the workers and adopting the tools which enhance the operational efficiency by cycle reductio. N. Cellular manufacturing, working in teams and stabilizing workflow, etc.
อย่าง et al.
2010 adds that when the different forms of wastes in lean culture are reduced, will in turn useful in managing the environmental waste by enhancing environmental performance. 1.3 Concept of lean manufacturing. The concept of lean manufacturing was developed by Toyota in 1950s to eliminate waste and maximize the process efficiency so that they can compete with the auto manufacturers in the US. Tools such as Kanban, Kaizen 5S, Value Stream Mapping (VSM) was used to achieve the objectives, and tangible results were achieved by the Toyota Production System (TPS). Prasad et al.
2020 Yana and Tiwari 2021
The concept was then applied to other continuous manufacturing sectors and decent results were achieved. During that time, good success was achieved in the industries with continuous process compared to the discontinuous manufacturing sectors. Industries such as textiles were not in the favor of implementing lean concepts at that time due to lack of knowledge and understanding of the strategies. Further, the management was not in favor of changing the existing production methods as they assumed that the manufacturing is done effectively. It was also assumed that the lean concepts work well for continuous processes or discontinuous processes with large volume and low variety of products. Furthermore, it was assumed that switching to new technologies from traditional technologies may lead to disaster and adversely affect the productivity. Lean manufacturing concept refers to the process from raw materials manufacturing to the delivery of the finished goods to the end user, with tactful management of resources resulting in monetary and time
saving.
It is sometimes referred to as just-in-time (JIT) systems due to their highly coordinated activities and delivery of goods that occur just as they need. Stevenson 2020. Lean manufacturing minimizes waste and in turn reduces costs, from which the technical term, lean, became popular ever since. Lean Supply Chain (LSC) is the smart way of linking a set of organizations by managing the up and downstream flows of funds, information, services, and products, satisfying the end user by the reduction
of cost and wastage. Tortorella et al. 2017
Lean manufacturing or JIT and supply chain management can be classified into upstream activities like procurement and supply, and downstream activities like distribution, which includes warehousing, transportation, retailing, etc., and the integration of logistics and supply chain activities. 2 Principles and tools of lean manufacturing. The fundamental concept of lean manufacturing is to eliminate the waste from the entire operations of an organization. In fashion and textiles, The lean manufacturing principles can be implemented in product design, sourcing, manufacturing, inventory management, quality assurance and packaging, Chiano et al.
2019 มาโรดิน et al. 2017
Further, it can also be implemented in the maintaining good relations with the suppliers and customers. Lean manufacturing aims at producing good quality products with less inventory.
less error less waiting time and less human effort วิกรามาซิงเง่and วิกรามาซิงเง่2017
The focus of lean manufacturing is to eliminate the activities that are not adding any value to the product and for which the consumers are not willing to pay. There are various tools that help the lean manufacturing to be successfully implemented in the manufacturing process. This section discusses the fundamental principles and tools used in lean manufacturing process. 2.1 Principles of lean manufacturing. The fundamental principle of lean manufacturing lies on defining the value of a product from consumer or final customer's perspective. Once the value stream has been identified, the focus then is to identify the existing and future value streams. Then various wastes in the existing value streams are identified and plans are made how to reduce and eliminate these wastes. Waste elimination helps to improve the productivity and efficiency while adding value in the manufacturing process, Cherifi et al.
2018
The 5 major principles of lean manufacturing are
1.
Principle 1. Specify values from customer or consumer are the manufactured and delivered to the customers following the principle soft pull approach.
5.
Principle 5. The process of identifying and eliminating the wastes is repeated until approaching to the perfection in the value stream.
เครื่องหมายสงวนลิขสิทธิ์ The Author S Under Exclusive License to Springer Nature Singapore Ltd 2022 R และยักษ์ S
Lean supply chain management in fashion and textile industry, textile science and clothing technology.
https:// ดอย
Org 10. 107978-981-192108 7_2. Challenges in the traditional fashion and textile supply chain.
กระบี่ยาน่า1 Department of Fashion Technology ชาฮิแชร์ Professor Industry 4.0 National Institute of Fashion Technology ดิลีอินเดียกระบี่ยาน่าอีเมลกระบี่ยาน่า admif in abstract
The fashion and textile supply chain is being hailed as the highest employment generation industry and engine of growth for early industrialization in least developed economies. The challenges in traditional fashion and textile supply chain are strategic as well as operational. While strategic challenges are structural and relationship related, generic across the world and stereotyped, some of these challenges are buyer dominance in the supply chain.
Diverging SKU in downstream
Network, sustainability and circularity issues due to fast fashion-induced overconsumption and lack of dependency on formal education. The operational challenges are more of execution-oriented, may vary across geography and market. Some of the operational challenges are long lead time, multiple iteration during product development, low penetration of technology and lower rate of digitization in manufacturing, overdependence on management philosophies, fringe use of scientific methods and confused perception of artisanal or industrial production. Moreover, the workplace often is ergonomically vulnerable. The chapter discusses each challenge in detail.
Keyword Strategic Challenge Operational Challenge Technology Education Lean 1 Introduction
Traditional fashion and textile supply chain is probably the most globalized and distributed supply chain for any products ever conceived.
For economic reason
It has been a standard practice in fashion and textile trade for yarn produced in one country to be woven into fabrics in another and cut components or partially sewn garments are shipped to yet another country for final finishing, Pogany et al.
1985
There are certain characteristics that are typical to the traditional fashion and textile supply chain, and specifically the manufacturing of apparel,
E Migratory in Nature Dickerson 1991 Ergonomically Vulnerable Workforce ยาน่า20084 High Labo Orientation Less Automation ยาน่า2018A Higher Participation of Women Workforce Lopez and Robert
Sun 2016 Less capital intensive and comparatively lesser threshold of tech knowledge requirement, Jana 2018 etc. While some of the characteristics are positive traits, rests build up the challenges faced by the sector. These challenges can be divided into strategic and operational in nature.
Strategic Challenge Live Driven Supply Chain เจอเรฟฟีแอนด์เมเมโดวิด2003 High SKU Proliferation ยาน่าแอนทิวารี2021 Environmental Impact Gadetti and Mewtwo 2015 Low Tech Adoption เจอเรฟ FI and เมเมโดวิด2003 ETC
Operational challenges are long lead time and iteration during garment sampling, JANA 2010, limited use of science and technology, JANA 2018, sewing operations vulnerability to RSI, CTD, JANA 2008C.
ETC 2 Strategic Challenge 2.1 Buyer Driven Supply Chain
A supply chain involves activities in the design, production and marketing of a product. And there is a critical distinction between buyer-driven and producer-driven value chains, Jarefi and Mehmetovic.
2003
Producer-driven supply chains are large transnational manufacturers, who play the important role in coordinating production networks, including their backward and forward linkages. Typically, capital and technology-intensive industries such as automobiles, aircraft, computers, semiconductors and heavy machinery follow producer-driven network. While apparel industry is a buyer-driven value chain that contains three types of led firms: retailers, marketers and branded manufacturers, Jarefi and Mehmetovic 2003. If we trace back the history of some of the oldest textile raw material manufacturers, we see that they are centuries old. Iconic fiber manufacturer DuPont was established in 1920 as Fibersilk Company. Courtauld was founded in 1794 as a silk, crepe and textile business, and lately Reliance Textile was established in 1960 and went on to become one of world's largest polyester fiber manufacturer. Traditionally, these fiber giants used to dictate the fashion trends, with their new developments showcased annually through some trend forecasting exhibitions like Premier Vision, France, Interstoff, Germany, to name a few. The brands, retailers, manufacturers used to take inspiration from such exhibitions to develop their next season's collections. In comparison, the fashion retailers are comparatively new. Walmart, the American discount department store chain, was founded in 1962. H&M, the Swedish multinational fast fashion clothing company, was founded in 1947. Inditex, the Spanish fast fashion, was founded in 1960s. By the turn of this century, these retailers amassed important consumer insight due to ready availability of point-of-sale POS data and through different loyalty programs, and started using that as power to dictate the contour of next season's development. The fashion and textile network has become a buyer-driven network. A major hypothesis of the global value chains approach is that national development requires linking up with the most significant lead firms in an industry, Jarefi and Mehmetovic 2003. Lead firms in fashion and textile supply chain are not necessarily the traditional vertically integrated manufacturers, nor are they necessarily involved in making finished products.
Rather Fashion
Signers or brands are private label retailers, located upstream or downstream from manufacturing, and involved in the supply of critical components or information. What distinguishes lead firms from non-lead firms is that they control access to major resources such as product design, new technologies, brand names or consumer demand that generate the most professor. Eatable return salt. How the raw material, manpower and logistics cost increased significantly over last 2 decades. Being a buyer-driven network, the retailers did not allow the retail price to be increased significantly to win over the consumer's loyalty, even sometimes reduced. For example, a pair of Levi's 501 jeans cost $50 in 1998, and in 2008 it is cheaper at $46. A Lacoste polo shirt went for $95 in 1998. The retail price of same in 2008 is $75. Wilson 2008. Factoring for inflation, each of these examples is resulting undue pressure on manufacturers to reduce cost of production so that the retailer's margin remains unchanged. Being a buyer-driven network, consolidation and infusion of technology happened at retail and warehouse domain, manufacturing left behind ignored. Secondly, scouring and migrating to cheap labor countries were motto for all brands and retailers, leaving very less scope for manufacturers to adopt technology. The recent reshoring, nearshoring initiatives is likely to infuse technology at the manufacturing domain.
2.2 High SKU Proliferation
Unlike automotive supply network, apparel and textile supply chain take the shape of matrix and not tiers. Massey 2000. The supply chain networks in context to textile and apparel may be completely disconnected, partially overlapping or completely overlapping. While disconnected networks works very similar to vertically integrated organizations, the completely overlapping networks in contrast works on globalization concept. Very common for fashion merchant. Dice sourcing from contract manufacturers in Southeast Asia. Figure 1 shows 3 different types of supply chain networks that are common in fashion and textile industries. Fig. 1 different supply chain networks.
ซอสยาน่า2010
Historically, companies managed linked supply chain operations by ownership,
e
vertical integration, Harrigan 1983, but rare to find now. Courtaulds had fiber manufacturing to retail functions in the
k Knox and Newton 1998
Some of the other recent examples of vertically integrated organizations are Lutai Textiles, Shahi Exports, Pratibha Syntex, to name a few. Lutai Textiles, a fully vertically integrated company in China with $1.3 billion turnover, manages an end-to-end supply chain that include cotton planting, spinning, dyeing, weaving.
Finishing and third Sewing
With 80% of business as textile production and remaining 20% as original design manufacturing (ODM) of shirts for other brands like Brooks Brothers, Marks and Spencer, Burberry, Kohl's and Lacoste.
Pratibha Syntex Ltd
Is a vertically integrated, sustainability-oriented, knitted textile apparel company in India with $75 million turnover that operates from farm to the finished product. It works with a total of 25,000 farmers, employs 6,500 workers and works with renowned global apparel brands across 20 countries like Patagonia.
Tag Timberland G-Star Zara H&M and many more.
Shahi Exports, the largest apparel manufacturer from India with $1 billion turnover, involves in spinning, dyeing, weaving, finishing and garmenting and operates 65 state-of-the-art manufacturing facilities. It is across India with a diverse workforce of 120,000 people. Approximately 70% of the fabric utilized is from their vertically integrated setup.
The company manufacture for brands like Tommy Hilfiger, Gap Inc., Decathlon, Kohl's, Walmart, H&M, Uniqlo, Calvin Klein, A&F, Marks and Spencer, Zara, Nike, and many others.
Supply chain of aerospace, home appliance, etc. follow a converging network or an A-shaped network that has numerous raw material (SKU) at upstream and limited variety of finished products at downstream, whereas textile and apparel supply chain fold. Low diverging supply chain network or a V-shaped network that starts with limited raw material (SKU) at upstream, but SKU proliferate as it moves downstream. Jana and Tawari 2020. For example, cotton fiber bale with a given staple length and micronair is single SKU, but when spun into 3 different counts of yarn.
Country SKU, now those yarn can be woven into 12 dip.
Farrant specification.